Well, hi everybody. Welcome back from spring break. I wish that I could see you all inside the classroom right now, working together, talking together here, but this will be our new classroom for the rest of the school year. I'll be making videos to help you, and we will also definitely have time within Google Hangouts to be able to answer questions and help you in any way that I can. This first page right here is definitions that most of you are already familiar with. We did this before the school let out, but I wanted to make sure that I just review it with you again. I also am attaching a PDF of this to the Google Classroom, so you can print it out if you want to have it to refer back to. Okay, so a line is something that connects 2 points. And it has arrows on both ends. It keeps going and keeps going. Look, it can look like this, and it can be written like this. The order doesn't matter. It could either be AB or it could be BA. All right, array has one endpoint, and it keeps going in the direction, but only one direction. It can't keep going in both directions. Now, when you name it, you find the one that has no arrow. This one goes first. The C went first. And then you put the arrow over the letter that kept going. So C and then D. For a segment, you have to have two endpoints, an endpoint here and an endpoint here. And the segment is the one that connects in between. Okay, it can be written either way as segment EF or FE. The order doesn't matter. Distinct. When you see some definitions, you're going to see the word distinct in it, or some problems. Distinct means that you're talking about two separate items. So it just has to be two different things that are on your page. Congruent, things that are equal in shape and in size. So angle M here is 70 degrees, and angle N here is also 70 degrees. So angle M is congruent to angle N. The congruent sign looks like this. Okay, collinear, those are points that lie on the same line. The keyword there is line. So all these dots, P, Q, R, S, T, they all fall on the same line, so they're all collinear. Coplanar are points that lie on the same plane. That's the main word right there, is plane. So all of these points, U, V, and W, are all in that same two-dimensional plane, so we call them coplanar. Perpendicular lines are lines that intersect at a right angle. They intersect at 90 degrees. That's this symbol right here. So in this case, segment AB going down is perpendicular to CD going left to right. And that's the perpendicular symbol right here, an upside down T. Means they're perpendicular. Parallel lines are lines that are never going to intersect. They do not intersect. So these two lines, EF and GH, are never going to cross. They're the same distance from each other. The symbol for that is EF is parallel to GH, so we use the parallel lines. Okay, so perpendicular planes are planes that will make or intersect at 90 degrees. So the blue one and the pink one make an angle of 90 degrees where they meet. Parallel lines are, parallel planes are planes that, again, do not intersect. So they have to be way across from each other. Just like the walls of our room or the ceiling and the floor, those are parallel planes. Skew lines are lines that are not parallel, but again, they do not intersect. So you have this pink line right here that is going one direction, and you have this green line that's going another direction, and it will never intersect because it's on a totally separate plane. Angle. An angle is a two-dimensional shape formed by two rays that share a common endpoint called a vertex. So the vertex is that point right there, the B, that is the point where the two rays meet. When it's written like this, it can be written three ways. Angle B, because there's only one angle at letter B. There's not a whole bunch of other angles coming out of it, so you can just use the one letter. Or you could say angle ABC, because the angles can start at A it can go through B and then it can come out through C. Or it could go backwards. You could call it CBA because it could start at C, could go towards B, and it can come out at A. Either way. Okay, and here's a circle. A circle is defined as a two-dimensional shape made by drawing a curve that is always the same distance from the center. So if you have this chord that comes from the center and it goes out to where the circle is, everywhere you go, that's got to be the same distance. It's like if a dog is attached to a bar in the ground, the leash will only let it go so far, and he would end up running around in a big circle. And every time you have one of these chords, it's called a radius, and the radius is the same all the way throughout the circle because it's always equidistant. Okay, so now I need you to go and find your Chapter 7 notes from before school closed. We're going to refer back to it even though you already have them filled in, but it's been a long time, and the examples or the problems that you have on Aleks tomorrow are going to refer back to some of these things. So hit pause if you need to, go find your notes, and then come back and hit play. Collinear lines that are points that fall in the same line. You remember those, specifically A, C, and B. And then coplanar are points that all fall on the same plane. And this one right here, that dot right there, is not on the same plane. It's sticking up out of that page. It's all of these that are actually on the same plane. So just know the difference. For segments, they have to have an endpoint or two endpoints, and in this particular one you have three of them. You have DE in blue, you have EF in pink, and then if you can look, you can see a bigger segment called DF. So there's actually three segments there within that particular one. Array, though, is different because it has one endpoint again, and it has one arrow, and it goes all the way forever in the distance of the arrow. Okay, you can review these examples that we did before school closed. Then we're going to try some on our own. So in this case, we're going to try to see one point and that goes along with the point C. Blank and C are distinct two separate different points that are collinear. There's going to usually be more than one answer. So if I'm looking at the point C here, then I'm looking for another point that is on the same line. So go ahead and answer the question. Okay, so your answer should have been either A or B. Either one was correct. Those all form a straight line with C. Letter B, ED, line ED right here, I'll do it in green. Line ED and another line are distinct lines, two separate lines that intersect. Okay, so here's the line that intersects, but the thing is with naming it, you have a lot of options. You can either say line AB, or you could say line BC, or you could say line AC, or you could even reverse those letters, BA, CB, CA. So there's a lot of options for that one. Aleks will accept any of those 6 choices. Problem C. A, blank, blank, and blank are distinct points that are coplanar. So you're looking for 3 other points that are on the same plane as A is. So looking at the A right here, I'll erase everything else. Looking at the A right here in purple, you need to look for 3 other points that are also on the same plane. Don't count the letter X because that's a plane, named for a plane. It's not, doesn't have a dot there, so it doesn't count as a point. Okay, so the 3 points that would have worked, and it could really be in any order, are B, C, and F. B, C, and F. Those are all points that are on this plane right here. D is not, it's way over here. And E is not because it's way over there. It's not on the same plane as the others. All right, and then lastly, we need to name another plane for plane X. So this one is the fancy script letter name. The other way to name a plane is to use 3 points that are on the plane. So I'm going to choose A, B, and I have to be careful about my third choice here because I have to show that it's a specific plane, plane X. If I chose C, they're in a straight line, and there could literally be an infinite number of planes that go through it. I need to distinctly choose point F, which is not on the same line as those. So that way I'm showing the 3 dimensions of the plane. If I chose C, it would only be 2 dimensions like a line. Okay, now flip over to 7.4 in your notes. And just quick reminder here, when you're labeling angles, this one is special because there's only one angle at the Q. That's why we're allowed to say angle Q, and then we can also say PQR and RQP as well. We can go this way or we can go this way, RQP. But over here at the letter A, it's not clear which one it is. That's why over here I never say just angle A. It doesn't work because which one are you talking about? There's an angle BAC and there's an angle CAD. There's all kinds of choices there. So you're only allowed to be specific with 3 letters. And they wanted us to find angle 3, so that's the one we did here. We did CAD and then DAC. For this first problem, write 2 other names for angle 2. Okay, so the answers you should have had were angle DBC and angle CBD. Next question is name the sides of angle ABC. So let me highlight that one for you. Here's angle ABC. So they want you to list the sides, the 2 rays. Make sure you start at the right point. Okay, so the sides should have been starting at B and going out from there. So one of them was BC. The B doesn't have an arrow. The C does. And starting from B and going through A. The B doesn't have an arrow. The A does. And the last one is to name the vertex of angle 1. This is angle 1 right here. So name the vertex. All right, so the vertex at angle 1 was the B right there. Okay, quickly, let's review some definitions. Acute angle is angles that are smaller than 90 degrees. Of course, they have to be bigger than 0. A right angle is exactly 90 degrees. An obtuse angle is greater than 90 degrees, but of course, it has to be less than a straight line of 180. And a straight angle is exactly 180 degrees, just like a straight line. So look at these. This one's 90. This one is 60. This one is 140. And this one is 70. So go ahead and name each one. Okay, so the right answer for this one was it's a right angle because it was 90. For B, it was acute because it was only 60, less than 90. For letter C, it was obtuse because it was bigger than 140. And for letter D, it was acute because it's smaller than 90. All right, quick review of the angle addition postulate. You have 2 smaller angles that can make a bigger angle. Small angle ABC right here, plus, or it's also on the inside, plus small inside angle CBD adds up to be the big angle ABD. And remember, this is review. We did this before school let out. So any setup of angles like that, you can figure out what a missing angle would be. If angle ABD was equal to 127, that's the big angle all the way across from A all the way to D. If that one was 127, and angle ABC was 32, that's this one right in here. If that ABC was 32, then find the missing angle. Well, in this case, I know the big number, I know the total, but I'm missing one of the smaller numbers. So in that case, we subtract. 127 minus 32, and we get 95 degrees for our missing angle. 95 degrees. Okay, so now you try some. Looking at this first one, Edpuzzle is going to ask you, should you add or subtract? Well, before we can know that, we have to know what we're dealing with. So first of all, angle LKM is this one right here, from L to K to M. And they told me that that one is 61 degrees, so I'm going to put that there. Angle 2, they tell me, is 39 degrees. Angle 2 is the one here with a 2 at the vertex. They tell me that that one is 39 degrees. The one they want me to find is JKM. So start at the J, go to the K, and then go over to the M. That's the one they want. It's this biggest angle right there. So would you add that? Would you add the two numbers 39 and 61, or would you subtract? Go. Okay, well, since these are the two inside angles, you would add them together so that you could get the total number. So when we add 39 plus 61, it comes out to be 100 degrees. So then you have the total amount. Okay, for the next one, again, let's put in what we know. In the figure below, we know that angle 1 is 97 degrees. Here's the 1. So I'm going to mark this angle right here as 97 degrees. And they also tell me that angle TSW is 146. The TS to W, that's the big one here, all the way across, from T all the way to W, the whole thing is 146 degrees. So now, go ahead and answer the question, will you add or subtract? Okay, in this case you would subtract because we already know the big number, the total of the whole blue angle. We need to know the missing one, that's angle 2, and that's this one right here. So we're going to subtract minus the 97, and we're going to get 49 degrees for our missing answer.